This tutorial will introduce you to the Vorview editing option under the main menu toolbar. Vorview is a meta-geometry program that will transform your model to a figure compatible for use in Vorlax. Vorlax generates various aerodynamic coefficients, such as the coefficient of pressure. First, let's add an MS wing part. Then, locate Vorview along the main menu toolbar and select Edit. Another browser will appear. The first step is to update the various parameters shown on the Input 1 tab. A more detailed explanation of these parameters can be seen in the user manual. For now, let's look at a couple in more detail. The iDetail parameter controls the amount of information presented in the Vorlax output window. A default value of 0 will present a summary of the input parameters and results. A value of 1 will present a detailed matrix list of the results. The parameters seen under flight condition are also important for execution. You can specify the different rates for pitch, roll, and yaw, as well as the reference free stream velocity. VSP will automatically fill in these values under the geometry section, but the user can also specify the geometry components. The Input 2 tab denotes the various cases that will be tested. Card 3 will specify what Mach numbers are being tested. For example, if you specify 3 next to n Mach, the Mach values of 0.5, 0.75, and 1.25 will be considered. Card 4 works similarly. If you specify 3 next to n alpha, angles of 1 degree, 2 degree, and 5 degrees will be considered. You can see a matrix of the results if you specify a detailed output by inputting 1 next to iDetail. You will use the Slice tab to edit the key slices that are seen in the main window. Key slices should be placed wherever there is a change in the slope of the geometry. Use the various options under Auto Slice to help with that. Auto Find will place a key slice wherever there is a slope discontinuity in the shape. Auto Eliminate will remove any unnecessary key slices. Auto Merge will combine key slices placed closely together. Auto Slice will place interpolated slices throughout the structure. And to save time, you can select Auto All, which will complete all of the steps above. To add a key slice, select Enable. Then use the Y slider to select the new position for the key slice. Finally, select Add. The Symmetry option will save you time and place a mirror key slice. To edit a key slice, use the arrows next to Select Key Slice to access a particular one, which will be highlighted in pink. You can use the Y slider to move the key slice, but only between two existing key slices. Use the num region slices to increase the number of interpolated slices towards the tip. Delete will remove the selected key slice and any interpolated slices associated with it. The Control tab will allow you to create and edit control surfaces on your model. Select Create to make a new control surface. You should now see CSF0 listed in the browser window. Then, edit the parameters under Create Control Surfaces as necessary. The first control surface that Vorview creates is by default an elevator, so let's name this Elevator. Click on the name listed to reflect the changes you've made. To place the control surface on the model, use the arrows next to Trap Number to locate the suitable trapezoid. These trapezoids are delineated by the interpolated cross sections. Then select Add Delete Control Surface. In order to delete the control surface, simply click Delete again. For now, let's leave the control surface in. Once you have finished editing the control surfaces, it's time to execute Vorview. Use the arrows next to number of subpanels to indicate the number of subpanels being implemented. Select Subdivide to implement these. Select Calc Surface CP to calculate the surface coefficients of pressure. As you can see, it takes a while. Then select Run Vorlax to get the final results. The results will appear in a window called Vorlax Output. Remember that you can control the amount of information presented in the output by denoting the value next to iDetail. The results will be presented in a matrix format. This concludes your introduction to Vorview and Vorlax.